Now we come to another concept, which is instantaneous velocity and speed. Now the average velocity tells us how fast an object has been moving over a given time interval, but it does not tell us how fast an object is moving at a particular instant of time. For example, if we have a position time graph, in this way, then the average velocity, suppose between these two time interval t1 and t2, this can be found out by finding the slope of this line. That is by taking the displacement of x2 minus x1 divided by the time interval. So if we take the displacement delta x divided by the time interval delta t, you'll get the average velocity. So this will give you the velocity in this time interval t1 and t2. But what if you want to find the velocity at say this particular time? Then to find the velocity at this instant of time, we'll have to use the concept of instantaneous velocity, or simply velocity v at that instant of time t. And this instantaneous velocity is defined as the limit of the average velocity as the time interval delta t becomes infinitesimally small. In other words, your instantaneous velocity, simply denoted by v, this is defined as the limit, denoted by this lim, limit of the average velocity, which is delta x by delta t, as the time interval delta t tends to 0. So here we know that the average velocity is this one, delta x divided by this time interval delta t. So here delta t tends to 0. It means that this line here, this distance here, it's very, very small. So what you have to do is you have to decrease this interval such that it tends to this 0. Okay, so this interval has to be very, very small in defining the instantaneous velocity. So you decrease the interval and you take the average velocity when delta t is very, very small, that is approximately equal to 0. You'll get the instantaneous velocity. And this formula, this we can write this as d dt of x. And this is another concept in maths. This is known as derivative, and this is read as ddt of x. So if you ask to take derivative of any function, for example x, with respect to the time t, then you write it as ddt of x. So the instantaneous velocity is given by this formula, ddt of x. And it is defined as the average velocity when this time interval is very, very small and it tends to 0. So you decrease this, slowly decrease till you reach this position here, equal to 0, approximately equal to 0. Obviously you cannot make it 0, approximately equal to 0. Then you take the average velocity, you'll get the instantaneous velocity. Now the concept of instantaneous velocity is very important, because when you travel from one place to another, you don't travel with a constant velocity. For example, if you're traveling from Shillong city to Guwahati city, again I'll draw a position time graph for that motion. So you're in a car and you're traveling from Shillong, starting from Shillong. So this is the position time graph. So you're starting from Shillong. So this is your starting point, Shillong, and this is your destination, Guwahati. So I'll just write GW. So you're traveling from Shillong to Guwahati, and while traveling from Shillong to Guwahati, let's say you are in Shillong city. First, say you're traveling very, very slow. Then as time passes, you may increase the speed. The vehicle may increase the speed. Then there may be traffic jam. So when there's traffic jam, the motion of the car is at rest. So that is represented by a straight line. Then after some time, the star starts moving, okay, increasing in speed, and then again, suppose you reach, say for a tea break or a lunch break, then your car will again be in rest, and that is represented by this parallel line. Then again it will travel, say slowly, slowly, slowly. Then it will reach this destination, Guwahati. So as you can see from your journey from Shillong to Guwahati, the motion is not uniform. Okay, so at these interval of time, the motion of the car is at rest. So here the velocity will be 0, and say at this point of time, since your car is moving slowly, okay, the slope here is also less. So if we draw this slope here at this point, it's less. If we draw the slope at this point, it will be large. If we draw the slope at this point, again large. And here also the slope of the line, it's large. So here you're traveling slowly, then fast, then at rest, then fast, then at rest, then slowly, then fast, then you reach the destination. So here you can see that the velocity, it's not constant at all. Okay, it's not in a uniform motion. At this point, the speed is slow. At this instant of time, the speed is slow. At this instant of time, it is fast. At this instant of time, it is 0. At this instant of time, the speed is fast. At this instant of time, the speed is 0. And at this instant of time, again, you're traveling at a faster speed. So at this, see that the speed is, or the velocity, sorry, the velocity is different at different instant of time. Hence, the concept of instantaneous velocity and speed is very important, because that will give you the speed at these instant of time. Now, average velocity, what will it give you? The average velocity will give you the velocity in this interval from here to here. Say it will take 2 hours, so from 0 to 2 hours. In this time interval, if we draw a line joining this starting point to this final position, then this slope of this line will give you the average velocity. But the instantaneous velocity is different. It's the velocity at any instant of time. If you are at rest, the velocity is 0. If you're moving fast, the velocity is large. If you're moving slow, the velocity is small. Remember, the slope of the line will actually give you the idea of the velocity. If your slope is very slant, the velocity is high. If your slope is not that slant, then the velocity is low. And if your slope is straight, if your line is straight, then the slope is 0 and the velocity is 0. So that is the idea of this instantaneous velocity. Now again, to understand this concept of limit as delta t tends to 0, we shall take the position time graph. So we consider the position time graph. Now in the position time graph, again here the object is not in the uniform motion. Since the position time graph is a curve, it is not a uniform motion. And here we can find at P1, okay, when your object is at position P1, the time is 3 seconds and the displacement is 2 meters. Then at P2, the time is 5 seconds and the displacement is 8 meters. So here we are required to find the velocity at 4 seconds. So what is the velocity at this 4 seconds? Now I'll draw you this graph. So this is the position time graph. So these are the 2 points, initial position P1 and P2, the final position. Okay, so the average velocity can be found out by finding the slope of this line P1, P2. Now to find the velocity at this time, at 4 seconds. So here this is at 3 seconds, and here this is at 5 seconds. So to find the velocity at this 4 seconds, what we'll have to do is we'll have to draw a tangent at this point. So this is a curve, so a tangent is a line joining this point. So this tangent, the slope of this tangent, will actually give us the velocity at 4 seconds. And to do that, what we'll have to do is we'll have to decrease the time interval. Okay, see, from 3 to 5 the time interval is 2 seconds. Okay, so we can consider this table here also. So this table can be used to find the limiting value of this delta x by delta t as delta t tends to 0 at 4 seconds. So here in this table again you see that when your t1 is equal to 3 and t2 is equal to 5, delta t is equal to 2. Now what you do is you decrease this t1, the time interval, delta t, you decrease this one. Suppose your t1 is 3.5 and t2 is 4.5. So here t1 is 3.5, t2 is 4.5. So again you can see that from this interval it has decreased to this interval. Then the time interval will be 1 second. Then again you decrease this by increasing this one from this 3.5 to 3.75 and this to 4.25. Again this interval is very small. Delta t in this case will be 0.5. Then again you decrease this interval so that delta t will be 0.1. So you make it 3.95 and 4.05, so that the interval will be 0.1. Then again you make it 3.995, which I cannot show you in this graph, and 4.005, t1 to be 3.995 and t2 to be 4.005, and the time interval will be equal to 0.01. You can see at 0.01 your time interval delta t is approximately equal to 0. Obviously you can go to 0.0001, okay, by decreasing the time interval. So in this case I'll take this in this table I'll take this 0.01 to be the time interval which tends to 0. So at this time interval tends to 0, we'll calculate this average velocity, and in the table, in the last column of the table, the average velocity is given for this time interval 0.01, and that is equal to 3.8400. So here at 4 seconds, the average velocity, the instantaneous velocity is equal to 3.8400. So that is the concept of this instantaneous velocity. It will give you the velocity at a particular time, that is in this case 4 seconds. Okay, you can see that in this table in the first row, this will give you the average velocity, which is how much? 3.92. Okay, but the last row will give you the instantaneous velocity because the time interval is equal to 0.01, which is approximately equal to 0. So you remember this concept. Average instantaneous velocity is the limit of the average velocity as the time interval tends to 0. Okay, and as delta t tends to 0, you will get this slope of the tangent drawn at this point, and that from the graphical method is the instantaneous velocity. Now we come to the concept of this derivative. This is a new mathematical method known as derivative. Now there's a formula which you need to remember. So you need to remember this formula. If you take the derivative of t to the power n, here n is an integer. Okay, here n is equal to 1, 2, 3, 4, 5. Okay, it can be 0. Okay, it can be minus 1. Okay, so here if we take the derivative of t to the power any number n, what you'll get is n t n minus 1. So you need to remember this formula because the displacement will vary with this function of time t. For example, if we have this x to be equal to, say, t to the power 3, then if you're asked to take the derivative of x, which is dt of x, this will be equal to ddt. You put the value of x, t to the power 3, and use this formula. In this case, your n is equal to 3, so this will be 3, then t, then 3 minus 1. So what you'll get is 3t square. So here you need to remember this formula very carefully. Then if you have another case when this is 0, so if this is 0, then anything to the power 0 is equal to 1. So here your x is equal to 1, and the derivative of this 1, so you put here to be equal to 0, and then here also 0, then here also your n is equal to 0. So 0 into anything will be 0. So the derivative of this 1 is equal to 0. So from here we learn that the derivative of any constant, be it 1, be it 2, 3, 4, 5, is always equal to 0. So if we are asked to take the derivative of 5, a number which is constant, so we take the derivative of 5 with respect to time, then this will be equal to 0. So you need to remember this also. The derivative of any constant, it's equal to 0. Then what about the derivative of simply t? Suppose your x is equal to t in the case of uniform motion. Then this ddt of x, this will be equal to ddt of t. So here your n is equal to 1. So here we have 1, then t, 1 minus 1, and 1 minus 1 will be equal to 0. So anything to the power 0 is equal to 1. So if we take the derivative of this t, ddt of t will be equal to 1. So this is also important. So you remember this formula. We'll have to use this in calculating the instantaneous velocity of non-uniform motion. So let us take an example. The position of an object moving along x-axis is given by x is equal to a plus bt square, where a is equal to 8.5 meter, b is equal to 2.5 meter per second square, and t is measured in second. What is its velocity at t is equal to 0 second and t is equal to 2.0 second? What is the average velocity between t is equal to 2.0 second and t is equal to 4.0 second? So here we'll have to find the instantaneous velocity at 0 second and at 2 second, and also the average velocity between the time interval 2 and 4 second. So here it is given that your displacement depend upon t as, I'll write xt to be equal to a plus bt square. So if you want to find the time, the instantaneous velocity, that is the velocity at 0 and 2 second, what you do is you take the derivative of this, differentiate, another word is differentiate this xt with respect to time. So here your v is equal to ddt of x differentiated with respect to time. Then here x is equal to a plus bt square. Then here, just like in the multiplication, you can take the derivative of a, then take the derivative of bt square. So here we have ddt of a is a constant, then the ddt of bt square. Now a is constant, you don't differentiate this one, so what you have is a ddt of 1, and here also this is a constant, you have b ddt of t square, and recall ddt of 1 is equal to 0, and in fact ddt of any constant is equal to 0. So here this one will be equal to 0, and 0 into anything will be equal to 0. And now we're left with b dt of t square. Now use the formula earlier. This is your n. So here dt of t square will be n, which is 2t n minus 1, so 2 minus 1, and 2 minus 1, this is equal to 1. So here your v will be equal to 2bt. So this will be equal to 2bt. Now b is given. How much is b? 2.5. So here, upon putting the value of this b into 2.5 t, what you will get is 5t. So here your v is equal to 5t. So the instantaneous velocity we found out is 5t. So now at 0 second, if your t is equal to 0 second, your v will be equal to, you just simply put this t here, v will be equal to 5 into 0, so you will get 0. Then at t is equal to how much second? 2.0 second. Then again simply put your t here, so 5 into 2.0, this will give you 10. So 10 meter per second. So for t 0 second, your v is equal to 0 meter per second, and for t is equal to 2.0, v is equal to 10 seconds. So this actually gives you the instantaneous velocity, the velocity at 0 and a velocity at 2 seconds. Now to find the average velocity from this formula, we'll have to find first the position at 2 seconds when t is equal to 2 seconds, and when t is equal to 4 seconds. So now we'll find the average velocity. So first what you do is you find x2, and this x2 is the initial position. So a, I'll write it as or simply it's just a, and plus b, and t here I've written 2, so here also I should write 2 to the power 2, and this 2 to the power 2 will give you 4, and the final position x4, so x4, this will be a plus b, again 4 to the power 2, so here t I've written 4, so here also t I should write 4, so 4 to the power 2 will give you 16. Now average velocity, this will be the displacement, initial position minus the the final position minus the initial position. So here your average velocity v bar, this will be x4 minus x2. Then the time interval, and here at this will be at t is equal to 2, and this will be at t is equal to 4. So the time interval will be 4 minus 2, so we'll get here to be equal to 2, and in the above formula you simply put x4, which is a plus b 16 minus a minus b4. So this cancel, then we have again here 16 minus 4 will give you 12, so you'll get 12b by 2, then we'll have 6b. So this will be the average velocity, and you put the value of b, which is 2.5, and here you'll get 15 meter per second. So this will be the average velocity, 15 meter per second. Average velocity is different from the instantaneous velocity. Now instantaneous speed, or simply speed, is the magnitude of the instantaneous velocity, or simply velocity. For example, a velocity can have plus 24.0 meter per second and a velocity of minus 24.0 meter per second. The instantaneous speed in both the case will be equal to 24 meter per second. So here we just remove the positive and the negative sign. So we can say that the speed is simply the magnitude of the velocity.